Welcome to this live chat facility tutorial. We have had a lot of questions recently about the chat facility and how to use it, so let's get into the video. The chat facility is built with students in mind, with a tool that doesn't need to be parent or teacher led. Each of our pages are linked to the person behind the broadcast, even after it's finished, so you can always ask your questions and get a response about the broadcast. So, let's have a look at how to use the chat facility. To use the chat facility, the first thing to do is to type your comment or question into the chat box. You can now enter your screen name. Your screen name will show when you type your question or comment. Now you will see the chat facility ask for your email address. As I mentioned before, each of our pages are linked to people from the organisation who can reply to your questions. You can enter your email address, which will not be shared with anyone, to get a direct response from the people behind the broadcast. If you do not want a direct response, then click the button at the bottom. People behind the broadcast can still respond to you if you don't provide your email address. This just means you may have to come back to the page to check the response. You can now speak to the people behind the broadcast and ask any questions you may have, or check out our partner pages to see the companies we work with who you can speak to right now about their current vacancies. You can also check out our careers page, which connects you to employers. Our live chat service is linked 24/7 to employers from a wide range of sectors, all waiting to hear from you. You can leave a question about how to produce a professional CV or how to prepare for interviews, anything work related, and one of our businesses will respond to you directly. You can also access a wide variety of live interactive broadcasts and video on demand with the live chat support on all pages. Now this bit is for the parents, guardians and teachers. The best bit about the live chat facility is that it is completely moderated, so you don't need to worry if your young person leaves a silly comment, as it will only show on their screen and no one else's. Another great thing about the chat facility is that it is GDPR protected, so no information is shared with anyone else. We will protect all email addresses and will never share personal information of the young people. If you have any questions about the chat facility or the Learn Live channel, please use the email us icon at the top of the page. Thank you, stay safe and stay tuned.
So the Pledge is a sort of organisation that tries to connect young people with businesses. So we work with schools and colleges and different organisations, so different charities and everything as well, to get young people engaged with us and into the workplace.
We got involved with the Pledge probably 3 or 4 years ago now. We went along to one of the first meetings and it was actually really exciting. There were a lot of people there from the local schools and local businesses. So from our perspective as an employer, it was great to sort of connect with local Macclesfield businesses, really.
The Pledge has been able to give me more confidence in myself. I think I've really been able to get on well with my employer because I've seen other employers being engaged through the Pledge.
I think it was in year 11, Jeva came in, did an assembly about the Pledge there. And that's when I first kind of properly, I'd heard bits about it, but that's when I first properly got an idea of what it was, and it was like that connection between schools and the workplace and demonstrating you can do more than uni and all that kind of thing.
I think it's important just to let us know the opportunities that are out there, because it's really hard to kind of find everything, because UCAS has a website for universities and employers don't really have one website, so Pledge can kind of be that bridging the gap.
They've put us in contact with countless local schools and charities and organisations. They approach us constantly to get involved in careers workshops and events that they've set up. They allow for meaningful contact.
Employing young people really helps us in terms of the energy that they bring. fresh ideas and being very committed to the organisation, and also they've got that enthusiasm for training and development, which will really help us further down the line.
But it's what you need to, if you need young people and new talent, you've got to go out and get it, because the students and the children are struggling to come to you. So you've got to show them that you're approachable and that you can do something that sort of means something to them.
Good morning everyone, and welcome to this COVID-19 Response Week on the Learn Live channel. The purpose of the event is to share an understanding of how COVID-19 has impacted on businesses. As a pledge team, we have maintained a careers information presence throughout Cheshire and Warrington. This specialist week will take that one step further by looking at industry within the current climate, sharing an insight into how businesses have been impacted, how they've been able to support the response to COVID-19, and the long-term implications for their business and industry. We have various businesses who will be answering the following questions. How has your business been affected? How has you been able to respond to the battle against COVID-19? And are there any long-term implications for your business following COVID-19? Now, next to the video player, you'll find the live chat facility, which is available to you 24/7 to ask any questions you have to our panel of experts from the construction industry. To type your question, simply click on the live chat box you will see next to the video player. There'll be also an @ symbol, which means your comment or question will be posted publicly for us to see. The email symbol means your comment or question can be sent directly to the person of your choice from the list that will appear. The live chat facility is always moderated, so think about your screen name and questions, as anything inappropriate will not be approved. Now, coming up first is a video from Siemens as they discuss the ventilator project, a collaboration between a number of large companies to provide 6 months of work within a 2-week period in order to meet the need for ventilators for the NHS whilst in lockdown.
A little bit of a background about me. I went to college. I studied maths, physics, chemistry, and graphic design at A-levels. I then went on to university. At university, I studied design with engineering materials, so kind of like a product design kind of course with a heavy bias as well on material science. That was really important. When you design products, you also need to know what material to select in order to build. As part of that degree, it was a 4-year degree because I chose to do an industrial placement. So that meant that I worked in industry for 1 year. I managed to get a place in Formula One. So it was a really important year for me to learn a lot. And I definitely recommend that practical work experience is super to apply theoretical knowledge. It's really important. So any work experience anyone could get is really good. After graduating, I wasn't quite sure where I wanted to go with my career. So I'd advise people not to rush. Take their time, step back. I did lots of different things. I worked various jobs in terms of at bar. I volunteered in a primary school. I also went travelling. I volunteered to teach in Vietnam. I went on a program called Monk for a Month to learn a little bit about Buddhism in Nepal. Did various sorts of travelling, and really realised that I wanted to get into sustainable energy. So when I got back, I spoke to the managing director of Siemens in Congleton, and he gave me some work experience. Now, Siemens themselves are one of the most sustainable companies in the world, so that's what I really wanted to do. So I'd got some experience in CAD from university, so computer-aided design, which helped me design some products in my course. And that was kind of my role going into Siemens Congleton, but it wasn't to design the product, it was to design the production lines. So just like an everyday product, like a mobile phone, let's take, or a kettle or a toaster, this needs a 3D CAD model, so it needs to be designed on the computer. After it's been designed, you can take various components and then manufacture them, which is machining various parts. But once you've got those individual parts, you need to be able to build them and put them together. And that is what an assembly production line does, just like a manufacturing plant for the car. So essentially, that's my job. I'm a plant layout engineer, and I design production lines, but also ensure that everything's nice and safe within the factory in terms of is there enough distance for people working apart and all that sort of thing. So why was my role, why are my skill sets so important for the ventilator project? So basically what we needed to do was, in a really short time frame, design production lines and then get them into a facility and ensure that we could ramp up production really fast of ventilators. Now, could we do that without a 3D model of all the production lines? It's quite difficult. You end up with lots of problems. So just like if you designed a mobile phone and you didn't actually design it on the computer first, you could end up with a screen that doesn't fit, a battery that's too big, could end up multiple problems. And that's exactly why we designed the production lines on the computer as well. So we need to ensure that everything fits, operators are happy, there's no snags, there's no problems. But also we need to upscale. We need to check that everything fits within the facility. How do we best arrange them to fit them in? And also we want to produce lots of ventilators. So we didn't just want one production line, we needed 16. So it's really important from a visualization perspective that we understood what this looked like. So it's really good as well to show various companies and say, look, this is what we're thinking of. And it gives everyone a really good idea of what we're talking about. Advice that I'd like to give to some youngsters out there looking at what they do with their career: work experience is massively important from my perspective. Get some practical application in a job and start to enjoy what that brings to you. And also take the skills, become rounded, learn how to communicate with people, learn specific softwares, things that you enjoy doing, and you'll gain a skill set that will be really important. Thank you.
Hi, my name's Rob Matthews, and I work for a company called Siemens, and I'm responsible for supply chain, so making certain we've got all the components we need to build the products that we make. And I want to tell you a little bit about a challenge that we were given. So around about the start of March, a group of companies were asked by the government to build some ventilators. Now, why are ventilators so important? You'll all know that we are living in very challenging times with COVID-19. And one thing COVID-19 does to some people is it badly attacks the lungs. And to help people to breathe long enough while they're fighting off the virus, ventilators provide that really useful function. But the challenge was that we didn't have enough ventilators in the NHS. So the government came to a group of manufacturers and said, right, okay, we've got a challenge for you. We want you to make 15,000 ventilators by the end of middle end of June, and we'd like you to start around about now, please. So who was involved? There were companies like Ford, McLaren F1, Siemens, Airbus, and a few others. And we got together to try and master this challenge of how to produce 15,000 ventilators. How do we achieve this? Well, my friends here, Elliot, Ben, and Matt are going to tell you how they achieved that. But let me just give you a quick intro of how they achieved it. They achieved it through fantastic engineering skills, brilliant behaviors, ownership culture, going above and beyond and working long hours to try and master some of these engineering challenges that we had. And they did it right in the middle of lockdown. So they did it virtually, most of them from their living rooms or their bedrooms. So I'm not going to say any more, but I'm going to hand over first of all to Matt, who's going to tell you how we mastered this challenge.
Okay, so my name's Matt. I'm 24 years old. I'll just start by telling you a bit of my background before I'll talk about the ventilator challenge. So for A-levels, I did maths, physics and chemistry. After my A-levels, I then went on to Manchester University and studied electrical and electronic engineering. I did a master's there, and then after that started to work at Siemens, and I've had my job at Siemens for 1.5 years now. So the job I do for Siemens is something called a production engineer. So what we do is we take a product which has been designed by our research and development department, and once they've designed the product, we then decide how that product is going to be built and what tools are needed to assemble it. So it sounds quite simple, but there are some complex problems underneath. So some of the problems are how much is it going to cost to manufacture the product and how we can make that cheaper to manufacture. Making sure that the product is built on time and reliably. So if we have machines in our process which keep breaking down, then that's going to cause delays and additional costs. And then how do we ensure that it's built correctly? Because there's no point in building a product if it doesn't work when it gets to the customer. So some of the skills used in this is there's quite a lot of problem solving. We need to establish how the parts go together. And if something's broken, then usually you're the person who needs to fix it. Also teamwork, working with other departments, and then also organisation to make sure that high priority tasks get done on time and to schedule. So with the ventilator challenge, what we basically had to do was we had to come up with a production line to be able to build these ventilators. And one of the first things I got tasked with within the team was looking at just the overall how to build the product. So we'd never seen this product before, and we were looking at it on our computers, looking at a virtual 3D model. So what we had to do was we had to just decide how it was built, because what we normally have is we build products on what's called an assembly line. So instead of one person building the product, which might take an hour, we split it out between multiple people, which breaks down that time. So we needed just a basic idea of how it goes together, so that we know where to split the different sections of the build process into different stages. So Elliot can do his job and look at the timings, and Ben can do his job and look at the benches. So once we'd got a basic build sequence, then we had to look at what tools we had to buy. So we're looking at electronic screwdrivers to be able to tighten screws to a certain amount, jigs to be able to hold the product in place while you're performing a complicated action or stop it from sliding about on a worktop. And normally it takes about 6 to 12 months to design production lines like this. And with this one, it was done in 2 weeks. So it was an amazing effort. So this product is a very complicated product because it's a medical product. And we were only building 2 of the final assemblies, so about half of the total ventilator. And each of those assemblies had 200 parts. So that's 400 parts altogether. So you can imagine the complexity of this ventilator unit. And there are 75 operators per shift, so close to 500 people in total are having to actually build these products. So some of the questions which came out is, how do we train that many people to build this product correctly when it's such a complicated product? And if you think about in your average school class where you've got 30 children, that means that there's 16 school classes that we needed to be able to train to build these things. And that's why the last task that I got given was looking at digital work instructions. So instead of having a paper one where people can just look at the picture statically, these digital work instructions basically played almost an animated build sequence, allowing the operators to be able to change the viewing angles, pause, and see the products virtually instead of just in snapshots. So that's really helped speed up the training process and helped drive down that time to manufacture. So next I'm going to pass you over to Ben, who's going to talk about the layout elements of the project.
So hello everyone, my name is Ben, I'm 28 and I'm a factory layout engineer. So essentially I've designed the production lines. So a little bit of a background about me. I went to college. I studied maths, physics, chemistry, just like Matt. But I also studied graphic design. I went on to university, studied design with engineering materials, which is a hybrid course between product design, and also materials science. And as part of my degree, I also did a year in industry, and that was also really, really good for me to learn a little bit, gain some skills, put theoretical knowledge into practice, but also just around me as a person. And I'd really recommend some work experience within your studies. I then went back to university, finished my degree, and then wasn't actually quite sure what I wanted to do. Now, that's not the end of the world. If you're not sure what you want to do, just take your time on it. So I had various jobs at the same time that I was juggling. I worked in a bar. I also volunteered in the primary school. I went abroad and volunteered abroad, teaching English, did various things and traveling. And then eventually realised I wanted to get into sustainable energy. So when I come back home, I spoke to the managing director at Siemens in Congleton, which is Andrew Peters, and I was speaking to him and saying, what sort of opportunities do you think I've got for my career? And Siemens are one of the most sustainable companies in the world. So I actually managed to get some work experience at Siemens in Congleton, where they make electric drives. And my role as I started there was to design the production lines and sort of reverse engineer everything that's there. So you've already got a factory, but we want to also design that on the computer, like a replica, a digital twin. So that's what I started doing. So 3.5 years later, I kind of got asked to come into this ventilator project. So kind of why was I included in this project? So if you take a product is designed, and our products at Congleton anyway, and just like the ventilator, would be designed on 3D CAD, so computer-aided design. And it's important to design it on the computer because you then need to be able to visualize the product. You need to check that everything looks like it functions correctly. And then you need to be able to send that information from computers to machinery to manufacture parts. Once you've got those individual parts, you need to put them together, and that's what a production line does. So essentially, I was in the project to design the production lines. Now, the reason why it was so important to design something in 3D is because we'd have problems if you just kind of prototype something or put it together as fast as you could. You'd have lots of issues with it. And essentially what we had was, from me starting the project, 6 days later, we'd already installed the first production line at the facility for the ventilator project. So that was the sort of speed we're looking at. Now, if we didn't have a 3D model beforehand to check everything, to check the fit, check the function, to check that all the operators and everybody was happy that everything actually fit inside the facility, then we would have had a lot of problems. So in that week, there was a lot of work in the background to make sure that everything was correct before we actually installed that first production line. So that's kind of what I did in the project. And we really had to make sure that, beforehand, there was less than 10 products a week being produced, the ventilators, and we had to ramp up to 3,000 a week. So it was no mean feat. We didn't just have one production line, we had 16. So we had to make sure that everything fit and also everything adhered to social distancing. So it was really important to be able to visualize that, see it in 3D, ensure that everything fit on the benches, so the product and also all the tools like screwdrivers, all of the raw material, these individual parts, be able to assemble them together. So that was the reason why I was in the project. But also we needed to simulate all of this and to check that the number of workstations and the number of structures with all the material were all correct, so it was most efficient, so we could produce the most. And that's the work of Elliot. So I'll just pass you over to Elliot now. Thanks for listening.
My name's Elliot, and I'm a higher industrial engineering apprentice. And I worked on the ventilator challenge, like Matt and Rob has just announced. And as a higher industrial engineering apprentice, I have to perform a degree that's part of the apprenticeship. So I'm doing a degree in control and automation. A bit of a background for me is I went to a local college and I did an A-level in product design and a BTEC level 3 in engineering. So that's how I got into this. And then I heard about Siemens and applied for a job in industrial engineering. So all about lean and making sure that the job is done efficiently in production and best practice is kept to as much as possible. So that's what my job is basically. It's keeping to best practice and making sure that our products within Congleton, Siemens, are built efficiently and the quality is what we need. So for the ventilator challenge, we needed to create timings from our bedrooms, our kitchens, all of this sort of stuff. All we had was a video from Penlon that was of an operator building this ventilator, and we had to break it up into little chunks and take timings from that video, and then we could input that data into what we call a discrete simulation software, and it's called Plant Simulation. It's another Siemens software, And from that simulation, we could determine how many ventilators we could make in a week or in a day, and how many operators we might need. You heard Matt earlier just say that we need 500 operators, and that number was generated from the model. So how many operators we actually need to build these products. But not only that, it was very important to the actual output. So to say to Ford and to say to the NHS, this is how many we can build, and this is the resources we need to build that many. And just to put it into perspective, this particular product that we're making, the ventilator, previously Penlon would make about 30 a week. Now we've designed this value stream to be able to produce 3,000 a week. So we've maximised production massively, and we've done that with the help of the digital tools that we've all used. Myself, I did the plant simulation, and just to get a feel for all of the tools that we used, I'll just show you a quick video now. So if I just show you this video.
So this is a computer model showing all of the production lines in the factory.
This is a production simulation of a ventilator factory showing time and how many products we can build in a day.
This is a sped up version of the digital work instruction to show the operators how to build the ventilator.
And this is a computer simulation showing a machine making a part to help operators build the ventilator. And here is that finished part that helps the operator.
Now here you can see the 3D version of the production simulation showing the human operators building and how many parts we can actually build in a day. And here's some statistical data that comes out of the model.
Here's one of the finished sub-assemblies. Followed by a picture inside the real factory.
Yeah, so that was the video, and there you can see all of the simulation, the CAD software, all of that sort of stuff that we used to make sure that this product could be built and deliver the product on time.
Thanks, guys. So that's the end of our presentation, and I hope you'll be able to see the challenge that we were given to go from 10 ventilators a week to 3,000 ventilators a week. And that was achieved with a great team. And I know that you all work in teams in your schools, and that teamwork will stand you in great stead through your career. It was built on great skills, life experiences, ability to communicate, maths and engineering skills. It was built on constant flexibility, receiving new information, thinking about how to deal with that, working in your team together to say, how do we solve the next problem? It was about working extremely hard as well, putting in the long hours to achieve this near impossible challenge that we were given. And what this team did was they made a challenge which seemed impossible, possible. And as a result of their engineering skills, their flexibility, their teamwork, this project is now delivering thousands of ventilators to the NHS and saving lives. And it's just one demonstration of how engineers working together with a common purpose can make a massive difference to people's lives. So thank you for listening, and have a great day.
Thank you to the team at Siemens. Don't forget to use the live chat facility to ask your questions, and check out the resources tab as well for more information, which you'll find on this page. See you back at 1 p.m. for a video from AstraZeneca, who are doing some fantastic work during these uncertain times. See you then.
So the Pledge is a sort of organisation that tries to connect young people with businesses. So we work with schools and colleges and different organisations, so different charities and everything as well, to get young people engaged with us and into the workplace.
We got involved with the Pledge probably 3 or 4 years ago now. We went along to one of the first meetings and it was actually really exciting. There were a lot of people there from local schools and local businesses. So from our perspective as an employer, it was great to sort of connect with local Macclesfield businesses, really.
The Pledge has been able to give me more confidence in myself. I think I've really been able to get on well with my employer because I've seen other employers being engaged through the Pledge.
I think it was in year 11, Jeva came in, did an assembly about the Pledge there. And that's when I first kind of properly, I'd heard bits about it, but that's when I first properly got an idea of what it was, and it was like that connection between schools and the workplace and demonstrating you can do more than uni and all that kind of thing.
I think it's important just to let us know the opportunities that are out there, because it's really hard to kind of find everything, because UCAS has a website for universities and employers don't really have one website, so Pledge can kind of be that bridging the gap.
They've put us in contact with countless local schools and charities and organisations. They approach us constantly to get involved in careers, workshops and events that they've set up. They allow for meaningful contact.
Employing young people really helps us in terms of the energy that they bring, fresh ideas and being very committed to the organisation, and also they've got that enthusiasm for training and development, which will really help us further down the line.
But it's what you need to do. If you need young people and new talent, you've got to go out and get it, because the students and the children are struggling to come to you. So you've got to show them that you're approachable and that you can do something that sort of means something to them.